In this video, we'll continue our discussion of Green's theorem, the circulation form of Green's theorem, by taking a line integral over the vector field. Our vector field is m, in. This is m, that is in. Right, and then they gave me the boundary C is bound by so this is a parabola turned upside down, shifted up by 4. So it's in pink there. It's covered up by red, but you can see the pink at the bottom. So that's that upside down parabola. Mine's kind of shifted over there. Not perfect, but it's by hand. And then y equals 0 is just the x-axis. So this path is in red there. I did the orientation going counterclockwise. We'll do our checklist real quick. For the boundary C, it is simple, doesn't overlap itself. It is closed, right, because it starts and stops at the same spot, so the path is good. The region R has to be connected. If I pick any 2 points in R and connect them, I stay in R. And then simply connected, remember, is that if I put any open region, I can contract it down to a point, and that stays in R. I don't end up outside of R. All right, so there's my path. I just checklist everything for Green's theorem. It is going counterclockwise, so I can use Green's theorem. Let's go ahead and get the calculations we need, which is the partial of n with respect to x, the partial with m with respect to y. So the partial with x, be very careful here. This is -1. M with the derivative with respect to y is -2y. So we can see it's not conservative. They're not the same. And then if I write the partial of n with respect to x minus the partial of m with respect to y, this is what I'm going to throw in my integrand. I get -1 plus 2y. I'm going to rewrite that because I like my positives first, but it doesn't matter. Right? I can use Green's theorem. So I'm going to rewrite the problem here. Cosine of x minus y squared dx minus x plus inverse tan of y dy. I'm glad we don't even have to touch that thing. This becomes the double integral of r over 2y minus 1 dA. Right, so I can now make this the double integral. If I go up here, y looks easier to bound with functions than x. X, I would have to turn things sideways and it gets gross. This goes from 0 up to 4 minus x squared, and then this goes from -2 to 2. So x is -2 to 2. Y is 0 to that parabola. And then I put 2y minus 1 inside here, put my bounds where they go, dy dx, and then it's just a nice, pretty double integral. This answer is going to end up being 352 over 15. You should work that on your own to match it. There we go. Green's theorem again, the calculation being fairly easy. Now I am skipping this part, but they're just nice, easy double integrals. You could do one integral and then let the back half be your calculator if you needed to do it quickly. All right, there we go.